and all three communities are vibrant. All three communities are growing very strong.
French English with partnership.
It's okay. I think I was following. Try to make it easy to interoperate in all the query engines available on the market.
Hey, today I am with Quentin and Kyle, specialists of file format, Onehouse, Apache XTable, Apache Hudi, and I believe the first to send a commit on Unity catalog OSS project based on Michelle. So we had the talk with her, I think, last week, and she mentioned that you were the first one building this demo in like 2 hours, maybe.
Quick turnaround on it. Yep.
That's amazing. And can you introduce yourself first to the community?
Yeah, thanks. Thanks for having me on the show as well. My name's Kyle Weller. I am head of product at a new company. It's a startup called Onehouse. You can check us out at onehouse.ai. I've been in the data space for about 10 years myself, building different data platforms, building different data products. I was at Microsoft for a long time. Right before I joined Onehouse, I was also a product lead for Azure Databricks. So very close to Databricks friends there. And I was on the Microsoft side of that first party relationship. And when we first launched the product on Azure, up until I decided to jump ship and start building this new company, Onehouse. So in the same space, in the Lakehouse space, and excited for the future of what we can build.
All right, amazing. So today we want to focus on XTable and see how it's working, what it does. But maybe before we start on XTable, could you give us a recap of the main file format available here? I know there is Delta Lake, Iceberg, Hoodie.
Yep.
Can you share your vision on that and
Yeah,
which
definitely.
one maybe works for what?
Yeah, definitely. And this is kind of some of the motivation of why we created and invented Apache XTable. Originally, it was named OneTable, and the idea and premise was because there are three very popular open source table formats out there. There's Apache Hudi, there's Delta Lake, and there's Apache Iceberg. And all three communities are vibrant. All three communities are growing very strong. And each project has various specialties or features or areas where it shines. And especially when you break it down into use cases, and you think of just like take a step back and think of just what is an open source community in general, right? It's a collection of people that are working on similar problems and trying to solve similar issues. And so they build this project together. Hundreds of different companies collaborate and contribute to these projects, all three of them, and they're crafting the project in a certain way to meet their needs and use cases. So if you look across them, that's where you see some deviations in how the projects work and operate and what they solve for. So without going too into the weeds, we can go there if you want, of like the differences in the table formats. What we saw from a Onehouse perspective, because we have a goal to try to build what we call a universal data lakehouse, try to make it easy to interoperate in all the query engines available on the market. And what we saw is many of our customers and many in the community were overwhelmingly asking for, hey, I need to use multiple table formats actually, because of, some of this stems from some vendors only choose to support one format. I think most vendors support all the formats or multiple formats, but a couple only choose one. And because of this, that kind of like pins a user out there in the wild to like force their hand into a choice of just one format, which they and in many cases they didn't want to have this choice put before them, or they chose a different format for other purposes. And so we had an overwhelming push from users on like, hey, can you help me use Hoodie and Iceberg, or Hoodie and Delta, or Delta and Iceberg, and because I need to use things like Databricks and Snowflake together in a combination for very good reasons or purposes. So that's where we first announced that we were going to build OneTable, and we searched in the community to see if there were like-minded folks who also felt this need, and very quickly both Microsoft and Google came to the table, and they said, hey, we're really burning on the same need. Like, all of our users inside of our cloud products, they need this flexibility, they need this interoperability. So they came on board very quickly. We co-launched the project in November with Microsoft and Google. Then we donated it to the Apache Software Foundation just a few months ago, earlier this year. And yeah, now it's Apache XTable, and the community's growing. We're very excited about the momentum now.
And I've seen a very interesting code in the Xtable Apache Xtable webpage. Choose openness, not storage wars. And I think this is a very, very important code. And that's it's following my question. Does the format matters these days?
Yeah, good question. Good question. I think 2024, honestly, I feel like is the era of interoperability. Um, and of course, I wear some goggles here based off of my position, what we're trying to build, right? But also seeing this validation and movement from more folks, even from Databricks, right? Databricks this year purchased Tabular, and also you saw Ali Gotzi on stage at the Data and AI Summit. There's a big focus of investment and area that way of like, hey, let's create. I think one word that I liked that he used was like a USB. What did he say? USB of table formats or something like this, right? And so, alongside Apache XTable, there's also other movements as well, like a Delta Lake Uniform and things that help go towards this mission of interoperability. Yeah, I think it's still very important to understand what the table formats are doing under the hood, because then you can find the right match to your use cases of like, hey, which table format will give me an extra edge of cost savings or performance or these kind of things. But at the end of the day, you don't have to, because I've seen organizations, I don't know if it's the right word, have like anxiety about choosing a table format. And what that does is it slows down innovation, because now these companies, instead of just moving forward on their data platform build, they'll carve out some like research project and spend some 3 months to build a benchmark, to build a test, and go compare all these things and then go battle it out. You've got camps internally of some that like prefer one or some prefer the other. And so it goes through this whole circus that can just be avoided. Of course, still do your research, still do your testing, pick something that's good for you, but also you don't have to be worried about like being locked in, because it's flip of a switch. You can switch to the other format. So if you feel like down the road you made the wrong choice, flip immediately to other table format, or even you can use multiple simultaneously now with something like Apache XTable. So I think that lowers that barrier of decision making, and makes it so that it's much easier to mix and match.
Oh, yeah, sure. So I wanted to ask you. So you are working for Onehouse, who is also the creator of, like, the original creator of Apache Hudi. I feel like Hudi is maybe the less, I would say, understood or well-known project
Sure.
of the three being, well, Delta Lake, Iceberg, and Hudi. Can you share a few more details on Hudi? Like, how is it working at a high level, and what's a good use case for Hudi compared to the others?
Yeah, great question. Yeah.
Kyle, that's the discussion we had, that the fact that Hoodie is not well known in Europe. Remember?
Okay, yes, Even different locales or regions. Of course, there's different distribution of communities across those as well. So yes, Apache Hudi. I'll start with a baseline that like if you look into any measurable statistics out there, whether it's contributors or users or other things about that, attempts to measure community size or growth or adoption, Hoodie's size and adoption is very great. And even when it comes to like contributors and things, there's even more there than there are even for things like Iceberg or otherwise.
Yeah,
but besides that, it's go ahead, Quinn.
And I think at the beginning, AWS started to build everything on Hudi. If I remember correctly, it was like the main thing.
Yeah, historically, it had a first mover advantage because Apache Hudi was created in 2016. So it was pre-installed first in all AWS services. Now, Iceberg has been added since like 2020 or so, maybe 2021 actually. I can't remember the dates for sure offhand. So yeah, there's some first mover positions inside there. More to your question of like, what is it and what are some of the use cases inside there? So I'll start with similarities first. Similarities are very close in nature to what like Delta Lake or Iceberg offer. Some that foundational under the hood, it's Parquet files. And there are like Delta Lake has a transaction log, Iceberg has manifest files, and Apache Hudi has what's called a timeline on top. And the goal and purpose, these are all like different ways to describe similar metadata. The goal and purpose is to provide ACID transactional guarantees, which all three projects offer, the ability to mutate that data on storage. It also provides advanced statistics around the files to make it so that queries can access that data much faster. And can really get into, hey, how do I skip past all these files that I don't need for certain query types, right? Now, where things start to differ or deviate is maybe when it comes to some specialties that are around like more near real-time streaming. This is where Apache Hudi's community focuses very hard on building, because as we talked about earlier, the communities naturally grow around these use cases. So folks that are like-minded around like lower latency processing or near real-time streaming, those like-minded folks will come together and crank on those hard problems together. So Apache Hudi from the very beginning, if you look even into its like first commits or first release versions, it had these capabilities called like merge on read, which versus a style of writing called copy on write, which most systems have used up until recently. Now Delta Lake has similar characteristics. Now Iceberg has similar characteristics, but Hoodie's had these for many years. And what it offers you is the ability to, because how I mentioned these are Parquet files under the hood. Now Parquet files are columnar-based storage, which are well optimized for super fast querying and analytics. But they're also the most expensive to write, and they take the longest amount of time to commit to disk. And so what Apache Hudi does is it blends both Parquet files and Avro files, which are row-based. It's a row-based storage file format. And when it does this, so now it can absorb incoming data in low latency, and you'll have Parquet files that we call the base files, and it will use Avro for what we call these log files. And so this is like new data that's incoming. And now tools are given into the user's hands to help balance and choose when to take those row-based files and merge them back into the base files, the columnar Parquet files. And what this allows the user to do is craft in balance for how to choose your write latency versus your read latency, and balance that write latency versus write amplification, and some of these considerations that help you fine tune, especially around these ingestion paths. So when it comes to low latency data ingestion, these are some characteristics that folks are interested in trying Hoodie for.
And when you say low latency, can you give us a few examples? Like what's low
Yeah.
latencies?
Yeah, and I can talk about it from like real world perspective as well. So folks like ByteDance or TikTok, they have models that are trained. Of course, it's like some of the largest data lakes I've ever looked into or seen or witnessed as well. But they will in near real time help to inform the next video prediction on your feed. And so that data has to move very fast to go and run through inference and have a return to build the next like 4 videos that are going to be downstream of your thumb to predict. Or folks like Amazon for their package delivery system. They use Apache Hudi to help the routing decisions for the packages. So this again in near real time, and this could be maybe more in the order of minutes. I would assume. I don't know for sure, but in that sense now they can make decisions of which packages should get on which trucks to route them efficiently through the delivery system. And also, you've probably seen that experience maybe when you're ordering an Amazon package and inside the app, it will tell you how close the truck is. Or it's like, hey,
Hmm.
the truck's like 20 stops away or 10 stops away. And so, like, all those kind of systems are closer there. Does that help on the low latency question, Quentin?
Yeah, I think so. Yeah, and do you still have, because I used Hoodie, but it was a long time ago. Do you
Yeah.
still have like an online table which is on Avro, and then
Mm.
the like the baseline table on Parquet, and then you have, so you see
Yeah.
the two tables in your catalog? Is that how it's working?
Yeah, great question. Yes, so both of those file formats will exist simultaneously. And then what you describe is actually an interesting concept because we allow the user to query the table in different ways. And so we'll, like inside of a catalog, and so if you're doing this on AWS, like Apache Hudi has like a catalog synchronization utility. So if you synchronize these to Glue, Hoodie can register actually technically two metadata tables inside the catalog. And what these are, these two tables will point to the actual files in different ways. So if you want a query to get the most up-to-date data possible, and you're willing to pay a little bit of extra cost to scan through those log files, those Avro-based files. This is what is called merge on read, right? The name and term for merge on read is because during the read operation, you're merging those on the fly. Or you can query the table and say, hey, ignore the latest base files. I want my query to be as fast as possible. So we call these like read optimized tables. So like ignore those log files, only go after the base files. And so now someone can craft a balance right here where, when people start designing Lambda architectures, they'll have like, hey, this is my hot path. I pay more for my hot path because it serves these kind of purposes. And so they might have a downstream like Flink reader or something like that that they point on that hot path that does the merge on read characteristic. But other folks, maybe it's for some BI dashboard that people only use every once in a while, and it's okay for like 1 hour latency. And if you've tuned Hoodie's compaction windows to be shorter than that 1 hour latency, then they never even see a gap of up-to-date data. They just get the fastest queries possible. So it lets you like balance these together.
Yeah, and if I'm not wrong, in Delta switch from the copy on write to merge on read with the introduction of deletion vectors.
Deletion vectors,
That's
yes.
yeah. And so just to summarize what you have said so far, we have three formats: Delta, Iceberg, Hoodie. All of them are Parquet plus some metadata, except Hoodie, which uses Avro.
Mm-hmm.
But the main question is, how does Xtable work?
Yeah.
And before that, the previous name of Xtable was OneTable. Can you tell
Yes.
us a bit the story behind the change of the name?
Yeah, definitely. Yeah. So OneTable was the original name for the project, and that's how it was when we co-launched with Microsoft and Google. Now, when you go to donate a project into the Apache Software Foundation, like open source is a really, really interesting world. And as folks like read into it and really understand like what is open source, and even look at because a really key component of open source is governance, and like governance from a community perspective, for like safety even guarantees inside there, right? Because there's actually been some interesting stories even just this year where the rug has been pulled out from underneath folks on open source, and a project can like disappear in a matter of 24 hours, which there would be like many in a community using, and depending on, oh, it had Apache 2.0 licensing, so I'm safe to use it. These But the community without governance, or a project without proper governance, can like vaporize, and people don't recognize that. So we decided to donate, because a key part to this, right, is having collaboration across the Hoodie community, the Delta community, and the Iceberg community. That's the only way a project like OneTable, XTable could survive or win, right? And so we needed this project to be arm's length from everybody, be in a neutral zone where it's not like one of these communities could dominate or have control over the thing. So we donate to the Apache Software Foundation, and during that process, there are a lot of reviews that happen. There's legal reviews, there's trademark reviews, there's a lot of things that go on. And one of these, while there wasn't something related to trademarks or otherwise, there's even a principle in the Apache Software Foundation that like you should also be sensitive to other types of things. So for example, OneTable, the name was very similar to the name of Onehouse, our company. And OneTable is also very similar to the name of OneLake, a new product that was launched from Microsoft. And so because the two of us were two of the three that were like on that initial list donating the project, there was a recommendation from someone in the community of, hey, let's be careful and not name it something that's too close to these initial committers here. Give it something more neutral. And so that's where we came up with Apache XTable, and now it's in the Incubator program in the Apache Software Foundation. So I think you asked me two questions though. So what was the second one? You asked about the name origin and
The name, and I think like how it's working, like what's the magic
okay,
behind the
how it
scene.
works. Yeah. Okay, how it works in the magic behind the scenes. So, the first thing that people think when they hear about Apache XTable is the thing like, oh, is it just another table format? And there's that popular XKCD meme about like standards or something, and throw one more in the ring, right? So when it's easy to think that way on the forefront, but actually when you look at what it is, it's not a table format on its own at all. Like you cannot write data as an X table. You cannot read data as an X table. It just doesn't exist. X table is only in the middle, and provides interfaces to unlock the translation of metadata across these table formats. So to explain how it works, like we talked about in common ground across Hoodie, Delta, and Iceberg, it's all Parquet files under the hood, and then a specialized metadata wrapper on top. Now, Apache XTable knows how to read the metadata layers of all three table formats, and Apache XTable knows how to convert one metadata setup to another. And so in the operation of translation, it doesn't have to read any Parquet files. It doesn't have to rewrite any Parquet files, so no data is duplicated. And also when you look at the overall storage sizes or performance considerations here, right? Like in a 100 terabyte table, your metadata is still only going to be a few megabytes. Like it's tiny in comparison, or maybe it's tens or hundreds of megabytes inside there, but it's tiny in comparison to the actual data and table size. So reading that metadata is a lightweight operation. Translating that metadata is a lightweight operation. And so all of this can happen asynchronously. XTable in its first iterations here, the way that you can execute it is you can just package up a jar file and run that execution however you'd like to see fit. So I've seen people in the community that will run it in line with the write operation and say, every time I make a commit, do a metadata translation. Or I've seen some people that'll take it asynchronously and trigger it once an hour or once every 5 minutes. Or I've seen people now, even AWS just published a blog where they operationalize it inside of the Airflow offering that they have, MWAA. They're long acronyms that they like to use. So you can put it in like Airflow and run it in triggering a pipeline cycle. Even folks like Microsoft and Snowflake are now using the project together. They just announced at the Snowflake Summit that collaboration with Microsoft on OneLake. And so even Snowflake now, when they write tables, external Iceberg tables to OneLake, behind the scenes, Microsoft auto translates that to Delta. And vice versa. When Fabric writes data into Delta on OneLake, it auto translates back to Iceberg for Snowflake. So they're using also the open source project for all their customers as well. Hopefully that describes.
Yeah, and I think it's amazing because like you don't have any dependency when you read or write the data,
Mm-hmm.
and you only have
Mm-hmm.
to build like have some kind of maintenance on the side and doing the conversion in the background,
Yeah,
which I think is super good for adoption because you don't have now to fight with every single vendor and every single instance to add
that's right.
XTable on top of everything else.
That's right. Yeah, it needs no vendor support to make the translation happen. It's completely independent. A vendor could choose to use it, like we use it in our product. And now I mentioned how like Microsoft and Snowflake now use it in their product. So vendors can choose to like make more wrappers around, but it's not necessary at all. And you can use it with any tool of your choice.
And and I'm curious. So you mentioned, for example, for Hoodie, that you have some specific options to do streamings and low
Yeah,
latencies.
yeah,
Um, I would imagine we have the same kind of specialties for each format. Like Iceberg is
yeah,
going to be good at doing something, Delta is going to be good at doing something. If you
yeah.
start using XTable, do you have to kind of standardize on, let's say, what's working the less
I
well? Like
see. I get what you mean.
if if you have Hoodie and you want to go with low latency appends and stuff like that, then if you turn on XTable, do you lose all the benefits because now you have to go as slow as, for example, Iceberg and Delta on this kind of operation?
Sure, sure. Great question. Yeah, and coming to like a least common denominator kind of factor, right? I think that's a valid concern. So also one other description of how it operates as well is in this flow, you are choosing basically like a primary writer, and you're telling what the other two, like which other ones you'd like as secondaries to be able to read. Okay, so you still make a choice of, do I want to write first in Iceberg, write first in Delta, write first in Hoodie, and then I can read it as all three on the top, right? And by so doing, then on the writer side, now you can pick and choose like which of the specialties you need inside those projects for write operations, and on the read side get some of those other benefits. Because now even when you think of that core base table, and even how you run maintenance on that table, because all these table formats need things like cleaning operations, or what Delta calls like optimize commands, or clustering operations, compaction, these kind of characteristics all the table formats need. So the maintenance is run, the best practice is to run that maintenance in the format of how it's being written as well. And so what this comes down to is um, you can actually still benefit from some of the specialty edges that are niche to the different projects that the other projects don't have, even with XTable involved. So if you take, for example, um, um, like if, because here on this base table, let's say we cluster that table, and let's say one project has like a specialized fancy way to cluster or sort the table, something like Z-order, or otherwise maybe there's something else fancy. Now you translate that to Iceberg. The only thing that changes is the metadata layer on top. All that data that has been sorted in the fancy way lives and exists and persists. So when you query it, your query engine can then still benefit from the way that the storage has been laid out underneath the covers. The edges where it exists today, because there are limitations to XTable, and those current limitations do include it not translating across merge on read base tables. So
Mm.
that includes deletion vectors from Delta, and Hoodie and Iceberg call it more traditionally merge on read that way. So those type of tables, it doesn't work quite yet. That's something that's being worked on in the community today. But then otherwise things like partition evolution, schema evolution, all these kind of things, they can translate across the projects.
Okay, so just to summarize, with the Apache XTable, you can write any format and translate it to other formats. So no matter what you're choosing on Delta Lake, Iceberg, Hoodie, as a primary format, you can seamlessly have this interoperability across all of those formats. But
Yep.
the main question is, how is this different from Delta Uniform?
Yeah, good question. Yeah, so the principles are the same, exact same principles and goals and things like that. And actually, even a lot of the implementation is actually the same as well. So, because I even personally meet with and collaborate with the folks that are building Uniform over there, and because we're aligned to the same vision and goal and things, and so we're open to share code, we're open to share ideas, and we're open to help ensure that the interoperability on our different legs works together. So you wouldn't choose to use both of these projects together, but we both want the three legs of Hoodie, Delta, Iceberg. We want all three of those legs working really well. And so we also share across these two communities of Uniform and XTable, we share, hey, we solved this in a certain way and it made this kind of way to translate more sustainable. And so we share back and forth that way. So because from the roots, right, and some roots of where OneTable comes from, some roots of where Uniform comes from, we've already been through table format wars, as you might call them, on of our own, and now it's like, let's move past this and let's just get interoperability, and so that's why there's a lot of good collaboration going on these projects too.
All right, yeah, and I think I saw there is a partnership between Uniform and XTable. Is that correct? Like a partnership?
Yeah, so yeah, we collaborate, we share code behind the scenes, we share ideas, we share development behind the scenes, and even Databricks has committed to help be on board and support XTable the same ways in reverse that XTable can support Uniform. So
cool. Okay, I just realized I did like a French English with partnership and partnership.
It's okay. I think I was following.
I think I have one more question. Like, how can folks get started with Apache XTable? And if you have any trainings, documentation links, or maybe recordings, that would be helpful. If you can point the community to where they can find those resources.
Absolutely. So we have a good website, xtable.apache.org. Let me just make sure I got that URL right if it's not the other way around. Yeah, xtable.apache.org. And from there, you can navigate to documentation up on the header, the nav bar on that website. There's documentation. There's a quick start inside there. There's a Docker demo. Those would be good places to start and try a little hello world example for XTable conversion. Then it also links to the GitHub page. So to get started, you go to GitHub, clone the project, just get started right away on your own. And then when it comes to helpful resources beyond documentation, there's also blogs on the XTable site. So you can go to blogs and those link to resources. Maybe a great video or material is you can check out even on the Data and AI Summit. I gave a talk there about Apache XTable. So that should be a great resource as well. I gave a great demo. And as you mentioned, I think at the beginning of this interview as well, I had a demo that integrated with Unity Catalog that was fresh off the press open source. It became open source that morning. I put a little coding in on the side, got it ready for the presentation just a few hours later. And so yeah, you can check out XTable, quick start demo, how to get started that way, and integrate with Unity Catalog.
Cool, amazing.
When did you implement this? Because I was with you at the lunch, then we took a cup together.
So that's actually an interesting story, right? So I wake up, I was very excited to get to the keynote because I knew some good things were coming, and I woke up and I was not feeling great. So I was at home I was in my hotel room, and I was watching virtually, unfortunately, and I was like bored on the side, and I'm like, okay, it's open source, let me just try it. And so I opened the GitHub. It was really easy to use, actually. And so seeing how simple it was to get started, I'm like, okay, maybe I could try this. Maybe I could actually squeeze it into my demo. So yeah, it only took an hour or two. And the only thing that I was nervous about was actually like delivering it and the demo gods being like happy with me that I'm throwing a last minute wrench into the equation.
What could go wrong?
It all worked out. Yeah. It all worked out though, and it still landed a good demo for the show. So.
All right, amazing. Well, thanks a lot, Kyle. Everybody, let's try, XTable. Go ahead, write the data once in the format of their choice, and you can make it available on every other format. So go ahead and give it a try. And yeah, Kyle, thank you very much. It was super
Yep.
clear.
Yep.
And we'll.
Thanks for having me.
Yep, sounds good. All right, bye bye.
Good chat. Let's do it
Bye-bye.
again. See y'all.